The VISUS methodology allows to assess also the fire hazard in the school complex. Here in this slide you can see two images acquired from a video where there were a large fire on a building and there was a person trapped here, as you can see outside, well, in an higher floor of the building outside in a balcony. Here this person is trapped outside the building, is in a very dangerous situation, and so the VISUS assesses all these cases, starting from what could happen, assesses the potential expected impact scenarios. So in this case, because this building was made of wood, a wood structure, there were widespread fire with a rapid propagation, and the fire caused a structural collapse, as you can see from the second image here. Where at the bottom, very small, you can see that the person here was rescued by rescue people. And obviously you have, in these cases, you have the total loss of contents and as we saw at the beginning, there is the presence of trapped people, and it was a very safe case by which this person was saved at the very last moment from the rescue team. So the VISUS methodology assesses several expected impact scenarios for the fire hazard, and assesses the potential interdependence of the school complex with the site. So, for example, if there is a fire in a building outside the school or outside the school complex, if this fire could also affect the school buildings, the school complex, or for example in case of a wildfire in the area that surrounds the school complex. Or if there is the potential propagation of the fires among the school buildings, and so a very simple fire propagates among all the buildings in the school. Concerning each school building, the VISUS methodology assesses which could be the potential fire consequences. So, for example, if there can be an explosion with the structural collapse because of the contents of the building, or because of the contents or of the structure of the building, if there can be widespread fire with a rapid propagation, as we saw in the previous image, with a very probable structural collapse, or if there is a widespread fire but with a gradual propagation, because the conditions of the building allow for a gradual propagation of the fire. And in this case, it's important to distinguish the rapid propagation from the gradual propagation, because there is the possibility for fire rescue personnel to act on the fire if it has a gradual propagation, so to limit the effects of the fire. It is important also to assess the smoke propagation, and if the fire is, for example, localized on the envelope, because the envelope of the structure is combustible elements. Also, in this slide, there are other expected impact scenarios for fire. Continuing, so we consider the loss of the structure, as I showed you in the previous slide, but also the loss of content in the structure, because also this is important. And the presence of the large fire in the schoolyard, the problem that people can be trapped in the school because of fire, cannot reach an exit, and so their persons can be trapped due to fire or smoke. Or if there are prevention systems, the fire could be suppressed by prevention systems. So overall, for the fire hazard evaluation, we consider the following factors: the presence of ignition sources, the presence of protections from the ignition sources, but the ignition sources trigger the fire or an explosion if there is a combustible element, if there are combustible elements. So there should be, for example, the envelope of the building could be combustible in case of wood envelope. And but there could be also protection systems that suppress the fire before it causes severe consequences. Then it is important to consider the functionality effects, so the egress of persons both from buildings and from schoolyard, and also how the fire could propagate in the school complex, so among buildings or from a schoolyard to buildings. So, considering the location, we assessed the potential interdependence with the context, and we assessed the presence of potential natural hazards. So if the school is within a forest, there could be potential wildfire interaction with the school. For the schoolyard, we consider the potential presence of ignition sources, such as, for example, dry widespread brushes, combustible material, and the presence of elements that protect from fire, like the fire extinguisher in this picture. Then, for each building, we considered externally the presence of combustible envelope, the potential interdependence between buildings. So in the picture at the bottom, you can see different buildings with combustible envelope and roof also, and they are very close to each other. So in case of fire in one building, the fire will very probably propagate from one to the other buildings. Finally, internally, it's important to consider the combustible contents, their disposal of combustible contents if they are very close or if they are propagated so fire cannot spread from one to the other. The presence of ignition sources near combustible materials, such as in the example in the picture above, where you can see a place for a small fire inside the building with a very combustible material. And also the presence of alarm system and the fact that there is a person trained to use the extinguisher or the fire suppression systems. The VISUS methodology assesses also the water-related hazards, considering therefore the potential floods, but also tsunami or other water-related hazards that could impact a school complex. Here I can show you a video of a school that almost collapsed. Here you can see now the collapse of a part of the structure. The school was built close to a river, and because of a flood, the foundations of the school were undermined with the roofs, and the school collapsed. So there is a very severe impact of the flood in this video. Here you can see the collapse of the school building. Fortunately, we were able to recover safely. For the water-related hazard, the VISUS methodology considers different expected impact scenarios. So we consider the presence of the impact of water on debris on the school complex. So the flood water can impact on the school complex, but the flood water can have different velocities and could bring also debris in the flood water that could hit the schools and the structure of the schools. Then there could be the structural collapse of the school buildings, or the school buildings could be damaged. In case of specific types of buildings, the building could be displaced interiorly, and so this could cause problems in the school or the buildings. Let's consider, for example, a container. It could be uplifted and move in another position. As you saw in the previous video, there could be the undermining of the foundations, causing also very relevant problems and collapses, but there could also be collapses of local structural elements such as a wall. Then there could be the partial undermining of foundation, for example, not causing the complete collapse of the structure, but also local small collapses. And a very important is the non-structural effects of floods that could, for example, cause the potential electrocutions of a person because of electrical contacts, or the potential dispersion of hazardous material. And also it is important to consider the potential effect of persons trapped in flooded areas or persons trapped in dry areas that are expecting rescue from outside. In this slide, you can find summarized the main factors that the VISUS methodology assesses for the water-related hazards. So the VISUS methodology assesses the hazard action, so the water action on the school complex, considering the water depth, the water velocity, the potential presence of wave action, the debris generation, and the local characteristic of the hazard. Then it is important also to consider the protection from these water actions, but also the presence of other natural hazards, such as, for example, landslides are often triggered by water-related hazards. And then for the buildings, it's important to assess the potential problems connected to structural collapses, displacements, the presence of losses inside the building, the presence of people trapped inside the buildings, or, for example, releases both in the schoolyard or in the school buildings, and also the egress, the presence of shelters and the presence of safe areas, as well as the presence of early warning systems that warn students and professors and personnel in the school to leave the school before an event. For the school hazard, the hazard can be defined considering past events, as we saw for other hazard, but also considering the hazard maps that are created for each hazard in the country. So if these maps are existent, for example, this is a map from a document with the water depth map for Mozambique. If these documents are present, they can be used for the assessment of the expected hazard. But as I told you, it is possible also, especially for flood events, to use the experience. So for example, there is in this building, there is a sign where they say, okay, you can see from this small image here, the water, this is the flood level on 16 August 2004, and okay, the image is here up to the roof of this building, so a very high flood level. For the water flood level, the VISUS methodology assesses different elements in different groups. So we consider, for the location inspection, we consider the wave action, the upstream slope of the site, in order to assess if which could be the water velocity, because the water velocity, as you can imagine, is a very important parameter for assessing how strong is the water hazard, but very often is not defined by hazard maps. So it is possible just to have an indication of the potential water velocity considering the upstream slope, and so to define which could be the velocity. Also, the water velocity can be modified by the lane roughness. So, if inside a city, if there are no straight paths and there are buildings, the water velocity could be reduced. Instead, on open lands, the water velocity could be very fast. It's important also, as we saw before, to assess the debris generation, because the debris could impact on buildings and cause very dangerous hits and the local characteristics of the site. Also, considering the topography, the presence of natural hazards such as, for example, landslides. For considering the schoolyard, it's important to see if the school complex is protected from water. For example, if the school is in on an elevated side, so in this case, even if there is a specific flood level, it cannot reach the school. So the school is a safe area, a safe place, because the water level does not reach the school. Obviously, in this case, children are in a difficult situation because they are blocked, they are inside the school and they cannot leave the school until the rescue team save them. It's also important to assess the potential presence of releases. For example, let's consider the presence of the toilets that should move the residuals away from the school, but in case of flood, this could not happen. Then, considering each school building, is also important to assess if each school building is higher than the expected water level. So, for example, in this case, you can see that the building is an elevated building, and in case of a flood with a water level lower, obviously, than this height, it is possible to the building is in a protected area. But also it's important to assess the water permeability and if there is a flood flow into the building, or if the flood flow is denied, because this changes the impact on of the water on the structure. So if the building is impermeable, the water cannot enter in the school and it acts only on one side of the walls, and it could cause collapses. On the other side, if the water can enter into the building, there is no single effect on one side of the building, but the water load is on both sides. And this does not affect the resistance of the wall, because there is no strong force on it, but obviously you have the water inside the building, and this causes other problems. One other problem of the water, considering the structure of the building, is that there are some materials that weakens when exposed to water. For example, a typical building built with mud, and this, in case of flood, obviously weakens and collapses immediately. But there are also other elements important, for example, non-structural elements. For example, there could be the contact with water of the electrical system, causing potential electrocution of persons in the building. And this happens very often, also recently, because of poor attention of persons on this. For example, in this case, you have in this image, you can see that there are electrical system on the ground, and it's very simple that in this case there could be electrocution of persons in case of flood. After the recent COVID-19 pandemic, we decided to change the VISUS methodology also to account for biological hazards. This part is still under development and has not been tested in projects because it's very new. But the VISUS methodology aims to assess how the physical environment of schools can is important for the biological hazard assessment. In particular, for the biological hazard, we assess how the physical environment of the schools, of the school buildings and of the schoolyard limits or not the potential diffusion of biological hazard, in this case of pandemic, because of the characteristics of the structure. So we assess the location, the schoolyard, looking if there is the access control of the persons and if there are potential zonations, so separation of persons and control of persons that enter into the school. For the school building, we assess if there is enough ventilation in each school buildings and if the access is defined in order to allow for an entrance and an exit of the buildings or from the building, allowing separated egress paths. And for each school building, we assess if in the school there are enough spaces for the children to be quite enough separated each other, if the layout allows this, and if the layout allows the separation of zones, and also the egress from the building, and also the presence of wash facilities, of water and health facilities. Finally, the VISUS methodology assesses also the ordinary use related hazards, that are all the hazards related to the regular use of the building, of the school complex, of the schoolyard, and of each buildings in the school complex. Here I want to show you a video of what could happen also during ordinary conditions. Just be sure that the child is safe at the end of the video. So you can see here that the child goes next to a rail, and he was very simple, and it folded because the rail was not a safe one. Okay, here the mother saved him. Unfortunately, they are able to pick them up again. This is just to say how there are conditions that could cause very, very severe consequences to person also during ordinary conditions, so during the ordinary use of a building and of a school. For the ordinary use assessment, the VISUS methodology assesses if the school is located in an unsuitable location, so if the location is not good for a school, if the school is simply or difficult reachable, so if in case of difficult reachability it's a potential problem, the presence of potential structural collapses also during, not because of a specific hazard, but because of regular use of the structure, the presence of elements that could cause the fall of peoples, tumbles or bumps, so everything that could cause problems to child during ordinary use of the school, or if there could be failures or potential contacts with dangerous elements. Considering the location where the school is, there could be unsuitable, for example, locations for a school, as in this example, where you can see that in order to reach the school, it is necessary for children to pass through a river, so without a bridge, obviously, as you can see from this picture, and this is the only entrance to this school. So this school is not in a suitable location for being a school, because children should cross a river to reach the school every day. So there also can be situations where there are unsafe transit from school and to school, or where there could be healthiness problems such as wetland areas. But also in the schoolyard there could be problems and children could be affected by dangerous situations during everyday use. So for example, if in the schoolyard there are unprotected holes, such as in this example, children could fall inside, or if there are unhealthy situation, considering for example unrestricted waste collection, or if there are, such as in this case, okay, there is a hole here, children could jump, could impact on these irons here that are unprotected, and also could fall from this height and hurt themselves. Considering school buildings, also there are plenty of situations where children can hurt themselves. So we consider the situations in case where children could bump or hit some objects, but also the situation where the structure is very weak for gravity loads. So as you can see from this picture, very representative picture, this school is not a safe place for children. Or there could be, for example, the presence of asbestos that is not a safe element to find in a school. Also inside the buildings there could be elements that could fall during ordinary use. For example, you can see here this piece of wood that could fall under the children. You can see the small children here in the bottom. Or in case of poor maintenance, so if there is mold inside the building, it's not healthy. Or there could be very easily reachable places that are very high and there are no protective measures from falls. So as in this picture you can see children can very easily reach this roof, but there are no protection measures and they can fall. Finally, as I told you at the beginning, the VISUS methodology assesses also the status of the school complex. So it's a complementary evaluation. It's not for safety assessment, but is a complementary evaluation that allows, that provides decision makers with further information concerning the school complex that allow them to take decision based on specific criteria. For the status evaluation, the VISUS methodology assesses different elements: the accessibility, the typology of content and equipment of the school, the water and sanitation conditions, the comfort conditions, the security conditions of the school complex and of the school buildings, the presence of constraints, for example, in case of interventions, if the building is simply reachable by the site construction personnel, and the maintenance of the school buildings and of the school complex overall in general. Considering the status, the VISUS methodology assesses the accessibility, the water and sanitation conditions, the content and equipment conditions, and considering this, here you have in these images how the VISUS methodology assesses these indicators. So for example, for accessibility, there are three classes. So the building, the school complex can be accessible, partially accessible. So for example, people with mobility impairments have a partial access to the school and to the basic services. Or it could be not accessible. So people with mobility impairments are not able to attend the school. The water and sanitation is very important, especially considering the COVID situation. So we also always have three classes where we have good water and sanitation conditions and hygiene is guaranteed. From the poor, when you have, for example, the absence of drinking water and you have very poor safety and sanitation conditions. Also, the contented equipment is an important status indicator, considering the contents of the building, of the school complexes, of the buildings in the school complex. So if there are high-tech contents or there is the minimal education equipment, so very poor contents. Concerning the status, VISUS methodology assesses also the maintenance of the school complex, the comfort in the school buildings, so if there is good comfort or if there are classes with uncomfortable conditions, and also a very raw evaluation of the security, so we assess if there is a controlled access to the school complex, or if a limited access, so there is no control access but the school is limited by fences, or if the access is uncontrolled and there are unlimited access, so everyone can enter into the building. Also, this is important in case, for example, of pandemic evaluations, where if there is the control of person, you can be sure that with persons that control the conditions of the building before they enter, you can a person can just check if they have cold or if they are unhealthy, so they can prevent them to go and stay with other children and spread the virus. And here you can see how they are assessed for the schoolyard, for the where we can see, okay, in this case there is a barrier for persons, for people with the mobility impairments, because there are these stairs to reach the school. In this case we can see that there are water facilities and there are waste receptacles and collection areas. And internal factors, we assess in the VISUS methodology the access to the buildings for people with mobility impairments, the water and sanitation conditions, the equipment, the content, the comfort, the security, the maintenance, and the constraints. The constraints for the installation of site constructions. So here in the example, you can see, for example, you can see the presence of hand washing facility elements, the presence of specific typologies of toilets, in this case conventional flush toilets, and the presence of computer laboratory as a content of the school. All the status conditions assessed by the VISUS methodology provide information to decision makers in order to assess on which school prioritize for the safety assessment upgrading, because also the content of the school or the status of the school is important for this assessment and for taking decisions.